Okay, we are going to skip a little bit and we're going to go ahead and move to chapter 12, which is on line plots. So, chapter 12, lesson 1 is analyzing line plots. I think you're going to like this lesson. It's on page 699, so go ahead and turn there in your math book, please. Okay, several students were asked how many blocks they walk home to school each day. The results are shown in the line plot below. How many students were asked the question? Use the line plot to help solve this problem. First thing I want you to do when you look at a line plot is the first thing you've been told to do every time you look at a graph. You learned this probably in the first grade. Look at the title. The title says distance from home to school. Next, I want you to look at the labels on the data chart. Numbers of blocks is at the bottom, and it shows you there's 1 block, 2 block, 3 block, 4 block, 5 blocks, 6 blocks, and 7 blocks. Okay. At the very bottom, it asks us, what can you tell about the distance most of the students in the group walk to school each day? What can we tell? There's several different things you could probably tell. Well, most of the students walk fewer than 5 blocks a day, right? The majority of the students walk how many blocks? You can see there's a lot of dots right above the 4, yeah. Okay, go ahead and turn the page. We're gonna look at a little more specific. Box A on page 700. A line plot or a dot plot. Why do you think it's called dot plot? Guess there's dots, right? Shows data along a number line. Each dot or X, sometimes you'll see an X rather than a dot, still a line plot, represents one value in the data set. In science class, Abby and her classmates performed an experiment in which they used different amounts of vinegar. The table below shows how much vinegar each person used. So they have a cups of vinegar chart at the bottom of that box, and you can see all the different amounts each student used. Really important, I do want you to look at our friend there. She says a line plot shows how often each value occurs. So it's just another way of representing data. You've probably seen these before, but we're just going to analyze them a little deeper than you might have done in the past. Look at box B. Read the line plot. A line plot can be used to organize the amount of vinegar in each person used. They say at the top it's for the lab experiment. At the bottom, we've got cups of vinegar, and they show you the different amounts. Box C says we analyze the data. Identify any outliers. Hold up, what's an outlier? Let's read about it. An outlier is any value that is very different from the rest of the values. So it totally stands alone, doesn't look like any of the others. The dot above the 3 in box B is way far away from the others. Would y'all agree? Most of the others are kind of on one end, and then the 3 is way out on the other. This value would be called an outlier. It's by itself. How does the line plot show which amount of vinegar was used most often in this experiment? This question is at the bottom. Well, if you look above the number 1 on that line plot in box B, you can see that the majority of the dots are above which number? 1, right? So obviously the majority of students, most of the students, used 1 cup of vinegar. It was used the most often. Okay, guys, that's about as hard as it gets, truly. I knew you'd like this lesson. Okay, page 701. Number 1. What is an outlier in a set of data? We just learned that. You can either copy the definition or you can come up with your own paraphrase of it. It's basically a value that is extremely different from the rest of the values on a line plot. Number 2, in the line plot on the previous page, do any values occur the same number of times? Look at that previous page. Are there any values that occur the same number of times? Yeah, there are. Which ones? Half and 1.5. They occur both the same amount of times. Both values have 2 dots above them. Number 3, describe any patterns in the line plot on the previous page. Well, I think it's pretty obvious that you can see most of them are between half and 1.5, right? So the majority of the pattern is between half and 1.5. I might say something like that. You might think of another pattern you could write. Okay, let's look at 4 and 5. In 4 and 5, use the data set to answer the questions. Okay, Mr. Rice's students ran a 40-yard dash in the following times in seconds. They gave you all those different times. I'm not going to read them and sound like a robot, but you can look through them. How many race times are recorded? They basically want you to count how many times there are. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 race times. That's the answer. Number 5, use the line plot that shows the data. And they've shown you the title is times in 40-yard dash, and at the bottom it says time in seconds, and they've given you the times. Which time occurred most often? Well, which one has the most dots? Which one is the tallest? 7.1 seconds. And yes, you need to write the word seconds because it's important to the data. 7.1 seconds, 7 and 1/10 seconds. Good job. Okay, let's look at the bottom. In 6 through 8, use the line plot to answer the questions. Let's look at the line plot first. The title is Orders for Cheese, and at the bottom it says amount in pounds. And they go 1/4, 1/2, 3/4, 1, 1 1/4, 1 1/2. Okay, number 6. How many orders for cheese does the line plot show? What are we going to do to figure out how many there are in all? Basically is what it's asking. We can count all of the X's, right? Same as dots. We just need to count them. So I see 2 above a 4th, that's 2. 4 above a half, that makes 6. 7, 8, 9. I'm going to keep counting. 10, 11, 12. There are 12 orders of cheese altogether. Good. Number 7, which amount of cheese was ordered most often? Well, look at the bottom. Which amount goes with the tallest column? A half. There are more X's on a half. So half pound is the most common order of cheese. All right, number 8. How many more orders for cheese were for 3/4 pounds or less than for 1 pound or more? Ooh, that had a lot going on there. Let's read that one more time. How many more orders for cheese were for 3/4 pounds or less than for 1 pound or more? So go to where you see 3/4. The first part of the question says, how many were for 3/4 or less? So how many are on 3/4? 3 plus how many are less than 3/4? So how many are on a half? That's less. 4. And how many are on a 4th? 2. 3 plus 4 plus 2. That's 7, 8, 9. There are 9 less, or 3/4 or less, okay? Then it asks for how many for 1 pound or more. Look at 1 pound. How many are there for 1 pound? 2. How many are there for 1 1/4? None. And how many are there for 1 1/2? 1. So that's 3, excuse me. So I have 9 for 3/4 or less and 3 for 1 or more. They ask you to find how many more of this are there than 1 pound or more. So what are we going to be doing when we hear the words how many more than? What operation? Subtraction. What is 9 minus 3? 6, right? The answer is 6 more orders. Guys, you've got this. I want you to go to my instructions page and look up which problems I want you to work. You're going to do great. Good luck. Bye. Okay, Garrett, that was the end of that one.